Can you hear me now?
Yes, sir.
All right, let's begin our last session for tonight. So in this last session, I will introduce you to an important concept and statistics. It's called probability. Probability. Now, the probability of an event means the likelihood of that event occurring, means that the likelihood that event will occur. So, or the chance that event will occur. So in other words, we have the probability is a branch of math that deals with calculating the likelihood of a given event occurrence, that it will occur. Now, an event with a probability of 1 is considered a certainty. For example, if you toss a coin, the event that it will land head or tail is 1 because it must land on its head or its tail. So long as it is a fair coin. Now, that's how the event that have a likelihood of or probability of 0 means that it is impossible to occur. So that in a 6-sided dice, if you toss to get a 7 in one dice, one 6-sided dice is impossible because it has sides from 1 to 6. So this I give you an example of what we are talking about here. Now we can express probability as a ratio or as a fraction or as a decimal or percent. So as a fraction, we can write it as this. Like they say, the event have 7 chances out of 10 chances, out of 10 possibilities. Or that it can be 7 to 10 or 70% or 0.7. They all mean the same thing. Yeah. Now, with this brief introduction, I will now introduce you to some basic concepts of probability. The first thing we're looking at is what we call the probability experiment. A probability experiment means a chance process that leads to a well-defined result that we call outcomes. Okay. For example, if you flip a coin, is a type of probability experiment because the outcome here will be either a head of the coin or a tail showing up. Okay, so it is a probability experiment because it leads to a well-defined result that we call outcome. If you roll a dice, of course, you know the coin. Look at the coin. This is the head. This is the tail. Now, for a dice, you can see the dice. How it looks like. Yeah. If you roll one dice, the outcome can be outcome as we roll a dice. It can be, let's say, the outcome. Okay, can be 1 showing up, number 2 showing up, number 3 showing up, number 4 showing up, and 5 showing up. I'm sure that you'll be asking yourself by now, why are we using coin and dice, the things we use in gambling? Well, the principle of probability theory, actually gamblers started it a long time ago, using it to win lotteries, Then eventually it was realized that this principle can also be applied to, so real life situation like business, education, and other areas, genotype, stuff like that. So that's why you see many examples we're doing here will involve gambling. Then I will also show you other areas that they apply. Now, how about if you buy a lottery ticket? Buying a lottery ticket is also a probability experiment because it has an outcome. Either that you win or you lose. Yeah? Or you lose. So that's the outcome. Drawing a card from a deck. and get any of the cards, it has outcome as well. So what is the meaning of outcome? Outcome simply means the result of a single trial of a probability experiment. For example, I have already explained when a coin is tossed, the head or tail, buying a lottery ticket, and so on and so forth. Another one is this: taking an exam, the outcome can be either you pass or you fail. Yeah. Now, next one is sample space. Now, the set of all the possibilities, all the possible outcomes of the probability experiment, we call it the sample space. The set of all the possible outcomes. For example, rolling a dice, the sample space is 1 to 6 for one dice. Now, if the event is selecting a day of the week, all the possibilities are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. These are all the possibilities. So we call it the sample space. Yeah. Now, sometimes we use a tree diagram as a way of displaying the outcomes of a probability experiments. We call it a tree diagram. You can use it. It goes in this form. Let's say that the event is. I think I have a tree diagram somewhere. But you can just say let's say a coin. You toss a coin. This is as here you toss a coin. Toss a coin. Then we can use a tree diagram to present the outcome. Toss the coin once. I'm putting it up so we can have enough room. So the outcome can be on this spot. Outcome. Okay. So for the coin, the outcome can be a head or a tail. See? That means to have head here. H for head and T for tail. See? So you can use a tree diagram to show those outcomes. See? This was just one of the examples. See, the outcome can be head. So we can use a tree diagram to show the outcomes of a probability experiment. Now, next thing is, like I said, I'm introducing you to the basic concepts of probability, the things we'll be meeting frequently as we answer questions in probability theory. Now, what is an event? Event is a set of the outcomes, a set of the outcomes of a probability experiment. We have two types of events. We have simple events. In simple events, we have one outcome. For example, if a dice is rolled and it 6 shows, then it is considered a single event. Say, rolling a dice and getting a 6, you see, is only one event. If you roll a dice and get a 2, so you can see it's only one event. So we call it a simple event. But in a compound event, you have more than 2 or more outcomes. For example, if you're interested in rolling a dice to get an odd number, a dice has 6 numbers, out of which 3 are odd numbers. So you can see that the event have more than 2 outcomes. So sorry, more than is 2 outcomes or more. So we call it a compound event. Okay. Now we can look at how to different explanation of the probability of an event. If the event have a probability of 0, that means it is impossible. I've already said that at the beginning. For events that are unlikely, it has probability of that is less than 0.5, which is less than 50%. So something like a lottery, probability is less than 60%. A lottery like a Mega Million, the probability is like at 1 in almost a billion. So the chance of winning that jackpot is 1 in out of a billion. So that one is much unlikely, so that people that win it are just have special grace. by chance, luck. Now, likely events have more than 50% chance or 0.5% chance because so they're likely to happen. For example, the likelihood that you get a job after you get a degree is more than 50%. It may not be 90%, but it's more than 50% since you are, educated. Now, we can now look at the different way we approach probability. There are three methods. We have one that is called classical probability. Under the classical probability, we use the sample spaces, the known sample spaces.
Wait, Professor.
Yes, sir.
Please scroll up real fast. My fault. Just for 1 second.
Yeah, go ahead. Have a question for me?
All right, now I'm good. Wait. Yeah, I'm good now. I'm good.
Okay, good. So for classical probability, we use this known sample space to estimate the probability of the event happening. For example, we already know that a dice have 6 sides. So we use it to estimate probability. For example, the probability of a 3 showing up or in is 1 out of 6 chances. The probability of 1 showing up if you toss a die is 1 out of 6 chances. The probability of all the numbers, each of the numbers showing up is 1 out of 6. So because why? We already know that a dice have 6 sides. The same thing with a coin. The coin has 6 sides. Sorry, have 2 sides. If you toss a coin, the probability that a head will show up is 1 out of 2 because it has 2 sides. The probability of tail showing up is 1 out of 2 because the coin have 2 sides. Now for the deck of cards, you all know how a deck of cards looks like. I think I have it somewhere. You can see right here. It's a deck of cards. So it has 52 cards on it. So we already know that it has 52 cards. The probability of each of these cards showing up is 1 out of 52. Why? Because we already know that it has 52 cards in a deck. So using the known sample space to estimate the probability of an event is what we do under classical probability. Okay. So under classical probability, the formula we use for estimating probability is this. When you see it's PE, it means the probability of event E equals number of ways event E occurs divided by the total number of outcomes in the sample space. So since it is classical, sometimes we may not know the sample space. So in that case, we have to estimate it using our own observation of the event or calculating the sample space by ourselves. That's when we do that, that means we're using the empirical probability, So in that case, we use ourselves, we estimate the sample space ourselves. Yeah, then we use the calculated probability. We'll come to that eventually. So these two methods, empirical and classical, is the one that we use most often. The third method, which is subjective, this one here, we don't use it often because it's not reliable, it's subjective. For example, a doctor may say that on the basis of his diagnosis, that there are 40% chance that the patient will need a surgery. Well, the basis of the diagnosis, it may happen or it may not. We have seen patients that the doctors predicted that they will not survive something, and yet they survived. Now, a seismologist might say that there is 30% chance an earthquake will occur in California in 2000, whatever year it is, Well, it's just making an educated guess. If it's based on real experiments, observation, then you can say that. Now, so because it is subjective, we don't normally use it often. Tonight, we're not going to go into the main business of calculating probability of events, but we're going to show you how to estimate the sample space an event. For example, it says, find the sample space for rolling 2 dice. Okay, The first dice have 1 to 6 sides. The second dice have 1 to 6 sides. So you're gonna have something like dice 1 and dice 2. You got dice 1 on this side. Okay. Dice 1. Okay. And you have dice 2. Okay. Now, this is dice 1, have 1, 2, 3, 4, 5, 6. And dice 2 have 1, 2, 3, 4, 5, 6. So when you toss the 2 dice at the same time, 1 might show up in dice 1 and 1 show up in dice 2. See? Or 1 might show up in dice 1 and then 2 show up in dice 2. So you have 1, 2. 1 might show up in dice 1 and 3 shows up in dice 2. So you have 1, 3. 1 might show us in dice 1 and 4 in dice 2. You have 1, 4. So you have 1, 5, just like that. Or it might be that 2 showed in dice 1 and 1 showed in dice 2. So you have 2, 1. 2 showed up in dice 1 and 2 showed up in dice 2. So you have 2, 2. Or that 2 showed up in dice 1 and 3 showed up in dice 3. Sorry, in dice 2. So you have 2, 3. So it's with that we have the rest of all this. It continues until you get to the dice, to the 6th number. Now we count all these numbers here. There are 6 of them. 1, 2, in each. This is 6 columns and 6 rows. So if you count them all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So the sample space will be equals 36 possible outcomes. See? So that's it. So like I say, we're not going to estimate probability tonight, but we will not learn how to calculate or find the sample spaces by event. How about this one? You have find the sample space for drawing one card from an ordinary deck. Well, a deck of cards, as we see, you have 52. A matter of fact, I can put it this way: you have how many suits? You have club, diamond, hearts, spade, and there are 13. How many cards in each suit? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 cards in each. So that means club has 13 cards. Diamonds, you can see diamond right here. It's also have 13 cards. Hearts also have 13 cards. And spades have 13 cards. So the sample space will be total of all this sum. So you have it in this form as, I'm gonna clear this. We have 13, 13 plus 13 plus 13 plus 13. Okay. See, I give you 52 cards. And that will give you 52 cards. I mean, sample spaces are 52 possible outcomes for 52 cards. See, that's how I find the sample space. Question on this? Any questions so far? Hello, scholars. Any question?
No, really for now.
Good, excellent. Now let me show you some. So let's look at this is like the last example we do for tonight. Then I'll take your attendance and we leave. Let's say that a family decided to have 3 kids, right?
Sorry, Professor, could you repeat what you said? You said something about attendance.
Yeah, I'm gonna check the attendance before we leave, so I'm gonna mark your
What
attendance.
is the actual classwork that we have to do?
Oh, the extra question. Don't worry, I'm gonna give you that. Yeah.
Okay.
So let's look at the something. Let's say that a family decide to have 3 kids. What are the possibilities for the gender of those kids? So it might be, of course, we can use B for boys and of G for girls, right? Okay. So we can use a tree diagram, okay, to find the sample space. So you might use here say I'm gonna have this. I have boys here. B. This is the first child, and then can be either a boy or a girl. Okay, so their first child can be either a boy or a girl. Okay. Yeah. So this is the what they call first, their first child. Okay. Now, a second child can be you can have it in this form. The second child can be a boy or a girl. So you go from this spot. For both of them, you have a boy or a girl, or a boy and a girl. Okay. So you can have a boy, girl, boy. Okay.
Professor, how long are we gonna be on the Zoom?
We're almost done.
Okay, I'm getting tired.
I know you're tired. Don't worry. We'll I'll soon leave you alone.
Okay.
And I won't bother you again until next week, okay?
Okay.
The second child, okay? Now, the last one will be the third child, okay? The third child can be either a boy or a girl. Some people have boy and girl. Boy, girl. Excuse me. I think I missed it. Undo. Then you can have a girl. So I got it. I know why it's doing that. Yeah, have this one. We also have here boy, yeah. So we use this to connect, the line for this part. So you gotta be boy, girl. So we have boy, yeah, or girl. Now, boy or girl. So now this is for this. We are got all this for this. So this is for the third child. This is for the third child. Okay. And this is something like 3. Okay. Now, so for here we have boy, which move it. Okay, so I'm gonna move it right here, so you can move it here. Then we got here. Now for this last one, we have our we got boy and gear. So we got here. We have it boy and here. So that our outcomes will now become so this, let's see the some possible outcomes. Okay, make sure I've seen this properly. Yep, I've seen it. So that we have it here, all the possibility outcomes. So we have, it can be that the first child is a boy, second child is a boy, third child is a boy. So we have the first outcome is boy, boy, and boy. Or the first child is a boy, second child is a boy, and third child is a girl. So we have boy, boy, and girl. So I'm gonna make it arrange so it will appear properly. Now it can be that first child is a boy, second child is a girl, there's a boy. So you have this right here. So the first child is boy, second child is girl, third child is a boy. Boy, girl, and boy. Or it can be that the first child is a boy, second child is a girl, third child is a girl. So you have it here as boy, girl. Now for this side, it can be that the first child is a girl, second child is a boy, and third child is a boy. Have it here as okay. Boy, girl, boy, boy. So we follow that pattern: girl, boy, and girl. Girl, boy, and girl. Or it can be 2 girls and a boy, like here. 2 girls and a boy. Here, girl, girl, and boy. Or it can be all of them girls, girl, girl, and girl. Okay, so it can be girl, girl. So that our sample space will be equal. How many possibilities? If you see any child family that have 3 kids, they must fall in one of these. It might be that all of them are boys, or 2 are boys and 1 is a girl, or they must fall within any of these possibilities. So we have how many possibilities? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 possible outcomes. Question on this? This is the last example for tonight. Any question on it? Any question?
No, sir.
Okay, good. So let me take your attendance so you can leave. Now, because you are having a test this weekend, I'm not gonna give you the classwork. So just study for the test. Okay.
When the classwork due?
No, I'm not gonna give you any classwork again tonight because you're gonna have a test this weekend. So just study for your test.
Okay.
Yeah. So just let me take your attendance and then you can leave. If I call your name, you can leave after that.
Wait, Professor, what was the sample space? 8?
Yes, 8. Yes.
All right.
Don't worry,
And Professor, for the test, we can just practice on the online thing.
yeah, everything we did from the beginning of the class to the last last session we had before this one. Okay, just pick one question.
Okay, got you.
Yeah. Arbota, you're there? We have Arbota, Sam Arbota, and Anya. Anya, you're there? Anya Statham.
I'm here.
Okay, so you can go now.
Thank you.
Jeffrey Chris, you there?
Yeah.
Okay, now you can go. Chris, Jeffrey. Yeah, I see right here. And how about this? Jones. Janik Jones. Got you. Taylor, you there? Diamond, Taylor.
Sorry, Professor. My
I'm here. Diamond Taylor's here.
All right, I will see you next week.
Okay.
Hey, Professor, my computer cut out while you were answering my question. I'm sorry.
No problem. I checked you now. Then Walker. Hashsiba.
I'm here.
Yeah. See you next week. IVR.
I'm here.
All right. Enjoy your weekend. Pearson Jadine.
I'm here.
Enjoy your weekend. Justin. Julia.
Battle. Like here, Justin Battle. I'm here.
Yeah, Justin. Yeah.
Julia Walker's here.
Justin Meta, right? Yeah.
Yes.
Justin Bad. Okay. All right. Enjoy your weekend.
You said Julia Walker.
Marcia. Huh? Say it again.
Julia Walker.
Yeah, I checked you already. So Marcia. Marcia. All right, Mr. Marcia. See you next week.
All right.
All right. Bowen. Noah.
I'm here.
Next week, enjoy your weekend.
You too. Thank you.
I got Selemani Maisha.
I'm here.
Okay, bye. Bagley Shade, right? Bagley Shade.
It's Sade Bagley.
Shade
I'm here.
Bagley. Okay, see you next week. Enjoy your weekend. Kimani. Kimani, you
Here.
there? Enjoy your weekend. Kikrin.
Here.
All right. Who else do I have? Sam Arbota. I marked you already. So
Yes, here.
I marked you already.
Thank you, Professor. Have a great weekend.
You too. Enjoy your weekend. Jones. Vitanik.
Hello.
Oh, okay. Yeah. Okay. I marked you. Got you now. I think we have everybody, I think.
Well, you have a good evening.
You too. It's 17. Okay, good. Excellent. So I'm gonna close down so I can